Okay, so today we're talking about how to prove lines parallel. Last week we talked about if you had lines cut by transversal, you had some special angles that were created. If those lines cut by transversal were parallel, those special angles took on a special relationship, right? What was some of those? What's the angles in the relationship? Alternate exterior. What was true about alternate exterior? They were congruent. What else was congruent? Alternate interior, corresponding angles, right? Okay, good. Then we had another one. What was it? Consecutive interior. What was true about consecutive interior? Supplementary. Very good. Then we learned one that said if you have a line that's perpendicular to one of two parallel lines, then what was its relationship to the second parallel line? It's also perpendicular. What was that one called? Remember? The line's perpendicular to one of two parallel lines, it's perpendicular to the other. It's called perpendicular transversal theorem. Okay, perpendicular transversal theorem. All right. So that's what we learned last week. Today we're going to work backwards. Okay, we're going to say if you can show these special relationships, then you can have parallel lines. Okay, and this is basically the converse of all the ones that we learned last week. So the first one is the corresponding angles postulate. And it says that if two lines in a plane are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. All right. So give me a pair of corresponding angles. Okay, 1 and 3. If I can show that angle 1 and angle 3 are congruent, then that's enough to prove that line A is parallel to line B. Okay? So if angle 1 is congruent to angle 3, then A is parallel to B. And this is the converse of the corresponding angles postulate. Now, abbreviation-wise, you could just say corresponding angles converse would be sufficient there. Corresponding angles converse. And the converse allows you to prove parallel lines. The regular corresponding angles postulate, you already know you've got parallel lines and you're proving that angles congruent. Okay? All right. Now I've got a postulate here called the parallel postulate. And it says that if given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. Okay? Kind of like the auxiliary line that we drew last week. You've got a line right here, and you've got a point that's not on the line. Then there is exactly one line that I can draw through that point so that these two lines are parallel to each other. Okay? It's a parallel postulate. Then we have these other theorems that are converses of the ones we learned last week as well. And this first one is the alternate exterior angles converse. Okay, and it says that if I can show that my alternate exterior angles are congruent, so like if angle 1 and angle 3 are congruent, then I've got parallel lines. Okay, so if I can show these two angles here and their alternate exterior angles are congruent, then I have parallel lines. The consecutive interior angles converse. If I can show that these two angles, 4 and 5, are supplementary, if the measure of angle 4 plus the measure of angle 5 are going to be equal to 180, then that is sufficient for me to prove that those two lines are parallel. We have the alternate interior angles converse. If I can show that they're congruent, that would be sufficient to know that I have parallel lines. And then we have the perpendicular transversal converse. Okay, and it's basically the opposite of the one we learned last week as well. It says that in a plane, if two lines are perpendicular to the same line, see how P and R are perpendicular and Q and R are perpendicular? If that happens, then those two lines are parallel to each other. In each one of these situations, it's the opposite of what we learned last week. It's the converse of it, okay? Last week we learned if you have parallel lines, then these angles are congruent or supplementary, okay? Today, we say if you can show these relationship with the angles, then you've got parallel lines, okay? So the converse shows lines parallel, okay? The converse shows the lines are parallel. All right. So let's work a couple of problems here. Given the following information, is it possible to prove that any of the lines are parallel? If so, state the postulate or theorem that justifies your answer. Okay, so let's say that I knew that angle 1 was congruent to angle 6. Now, my recommendation to you is to highlight the the lines that create those angles, okay? So I would need this line, and this line. That kind of makes it pop out. And are angle 1 and angle 6 a special angle pair? Yes, what are they? They're alternate exterior angles. So we can go to that theorem that says if alternate exterior angles are congruent, then the lines are parallel. So what lines would be parallel? L would be parallel to N. Make sure you use the correct symbol. And my reasoning would be the alternate exterior angles converse. And it's important that you put the converse on there because we're proving lines parallel. Okay, let's look at the next one. Angle 2 is congruent to angle 3. So again, if I highlight those lines that make those angles, 2 and 3 have a relationship, or are they a special angle pair? What? Alternate interior angles. So does that make me have parallel lines? Yes, because they're congruent, it makes me have parallel lines. So I would put, what lines are parallel? Okay, so L is parallel to M, and that's by the alternate interior angles converse. Okay, how about 1 and 4? Those are congruent. Does that give me parallel lines? It does? What kind of angles are those? They're corresponding? What would be corresponding with 1? 3 would be corresponding with 1. What would be corresponding with 4? Well, actually, we don't even have a number. It would be this little angle right there. Okay? So, is that sufficient to prove parallel lines? No. There's not a special angle relationship there. So, my answer would be no parallel lines. On one of your problems in your homework, you have to do a proof, and it's partially done for you. You're actually proving one of the theorems. Remember, when you're proving a theorem, you can't use that theorem in your proof. You have to use previous information that you knew in order to come up with that proof, okay? And like I said, it kind of guides you through it, so it's not too bad. All right. Now here's some different types of problems. It wants us to find the measure of angle MRQ so that A is parallel to B. This is MRQ right here, and I want to prove that A is parallel to B. In order for these to be parallel, what relationship do these two angles have to have? They are alternate interior, but in order for the lines to be parallel, they have to be congruent, okay? So I'm going to set them equal to each other. 5x plus 7 equals 7x minus 21, and I'm going to solve for x. So I end up with 28 equals 2x. Divide both sides by 2, and x is 14. Am I done? No, it's asking for MRQ, right? So I had to go back and plug it in for angle MRQ, which is 5x plus 7. So I'm going to do 5 times 14 plus 7. 5 times 14 is 70 plus 7, which is 77 degrees for MRQ. Any questions on what I did there? Okay. All right, what's going to happen here? It says find the value of x so that n is parallel to n. What's going to happen with these two angles in order for those lines to be parallel? Okay, these are going to have to be supplementary, aren't they? Okay, so I'm going to have to add 7x minus 2 plus 10 minus 3x, and that is going to have to be equal to 180. So that is, it ends up being 4x plus 8 equals 180. Subtract 8 from both sides. That ends up being 172. Divide both sides by 4. And that ends up being what? 43? Is that right? Is that what y'all got? 43? Yes? Am I done? Huh? Am I done? Yes, because all it asked for x. Thank you for checking. All right. So, how can we prove lines parallel? Talk about 4 different lines parallel. Okay, what's perpendicular to the first say? So if you can show that two lines are perpendicular to the same line, we got parallel lines. What else? Okay, what do you have to show for alternate interior angles, Converse? Give it to me. What does it say? I know, but in your English, what do I have to show when say alternate interior? What do I have to show about alternate interior angles to have parallel lines? Show that they're congruent. What else? Okay, what has to be true about consecutive interior angles? They have to be supplementary. They have to equal 180. Okay, what else? Two more. Alternate exterior. What has to be true about alternate exterior angles? Congruent. Okay, and there's one other way. Corresponding. What has to be true about corresponding angles? They have to be congruent also. Okay? Sometimes, to help these theorems make sense, you need to try to put them in your English. Okay? Does that make sense? Because when you just read all those words, it's just like blah, blah, blah. It's like, what was that on your peanuts? So it just sounds crazy. If you will draw a picture, or if you will put it into your own lingo, sometimes that will help you remember better. Okay? All right. Your assignment is on page 211.